Bismillahirrahmanirrahim, and Assalamualaikum warahmatullahi wabarakatuh, and very good morning to everybody. So for today is just a simple what I can say tutorial, something like that, regarding the NMR processing, because we have in a few new students will be using this kind of software we call TopSpin for broker, because we have 500 megahertz broker. This is the 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 machine look like. Okay, so this is the schematic NMR. Okay, we have three components in NMR. The first one is the magnet itself. Okay, so this is the magnets, superconducting magnets, is very powerful magnets. Okay, so in NMR history, the highest NMR with the magnetic blocks is 90 megahertz only. The rest for 300 megahertz, 400 megahertz, 600 megahertz, and when we try to increase the power of magnets, so they will use coil, and also between coil they will have a liquid nitrogen and liquid helium to reduce the heat. Okay, so this is the second one part is the NMR console. I will show with the real picture in our school. Okay, and lastly is the workstations. Okay, the workstation they are using NMR TopSpin also, but the workstations and the interface for the workstation is different for the operators and also the users only for the processing applications. So this is our NMR. Okay, for example, the computer here, this is the workstations. If you see clearly, the interface for TopSpin is different between what we use after, we will use after this. Okay, the second one, this one is the console. All the electronic boards is there. Okay, the last one is the magnet with the sample changes. Okay, if we don't have money, we can uninstall this one and do it manually. Just put the sample on the top, but manually. Okay, it's not really convenience if we have a weekend slot or long holiday slots, so it's okay. Okay, so if you see the color in the light here, can you see the arrow? Anybody can text me, chat box perhaps.
Cannot see, doctor.
Yes, okay, can see. Okay, if you see the light here, okay, change from yellow color is preparations. Okay, and the green color is experiment is running during the time. Okay, if they turn to red, don't do anything. You have to call me, Alia, or Fahmi. Okay, if you see. Okay. Okay, we have NMR 500 megahertz broker AVN. Please remember this name because you will put inside your document list when you're writing a thesis, when you write a paper. Okay, and we have a student changes here. We have 24 slots. It's a lot. Okay, so okay, they have a few part that we will discuss here. Okay, first we will prepare about the sample preparations. I will do this briefing is kind of routine. First, like a lecture. The second one will be a hands-on. So like I'm doing for Tahir, and also for recently yesterday for for Idris, please, and for everybody for the previous sessions, please make sure you alert about this one. First, okay, you should have a sample for the synthesis, at least 20 milligrams, for example, like that, to get a very nice NMR spectrum. Okay, for the natural product, if you have around 1 milligram, is still okay. Okay, because I have an experience with 600 megahertz. I have less than 1 milligram. The measurement is okay, but the NMR spectra is not really beauty. But we have a solution for that one. Okay, the second one is a selection of NMR tube. Okay, the normal NMR tube that we use in the picture like this is a 5 mm size. Okay, we have a 5 to 3 diameter size, but I don't buy it because it's expensive. And we have also 1.7 size, 1.7 mm diameter, very small. I have it, but I have to return to UM. But the one, and lastly, for the Shigemi tube is usually using for the NMR sample that we have less than 2 milligrams. Okay. If you have a sample less than 2 milligrams and you want to use a normal NMR tube, it's okay. But the difference is the resolution is not really good. And also for the carbon measurements and carbon measurement and 2D experiments measurements, you need more time to do it. Okay. And the third one, the selection of deuterated solvent and their reference for the deuterated solvent. This is very important because we need when you try to learn to submit the experiments to send the samples for the NMR, you have to mention what type of solvent you use, because if we try to proceed with the experiments without knowing the solvents, okay, the experiments before they try to lock the solvents, the experiment will fail and the color for that machine change from green to red, and they will stop all the experiment all the day long. Can you imagine if the experiment that you have submit on on Friday 6 p.m. and suddenly it's happened and the experiment for the rest on during the weekend is not proceed. Okay, please think about this information about the selections of deuterated solvent as carefully. Okay. The first one, okay, the usually solvent that we use is CDCl3. Why we use CDCl3 is kind of universal solvents. Is for me is cheap, okay, and they have only one deuterated isotope, okay. We have methanol D, pyridine, methanol D4, pyridine D5, acetone D6. We have benzene rings D6. I have benzene ring, but in my office. If you need benzene, just come to my office. So we have also DMSO. Okay, DMSO is the last choice if you want to use DMSO, because when you use DMSO, you cannot recover your sample back. This is very important. Okay, try every solvents. Okay, first by using normal solvent, not deuterated solvents, and choose wisely. Okay, because the choosing of solvent is also very important for the animal experiments. And also, if you try to change the solvent, the price for the solvent is quite expensive. For example, I guess for the MSO is 1,000 something price. Okay, for the CDCl3 is 400 plus. Okay, and the fourth one is the solvent levels. If you have this is the NMR tube, make sure you have only 4 centimeter high, 4 centimeter, and I will explain why. 3.8 to 4 centimeter is enough. Okay, because I see all the students put more. Okay, more than 4, more than, I don't know, because and when I see that type of solvent is DMSO. Okay. So this is kind of example. We have methanol D4 and this one methanol D4 in ampule size. This is we have pyridine D5. Okay, I will explain when we need to use D2O, when we need to use pyridine. Okay. Okay, I will give you this this NMR chart for you as a reference after this. So the thing that you have to check is the 1H chemical shift. For example, chloroform. Okay, 7.24. It should be appear as one in bracket called singlet. 7.24. Normally there has some debates what value you should use, 7.24 or 7.26. You can use both. There's no argument, but the famous number is 7.26. And if you run the carbon 13, okay, they have 3 peaks there, 3 peaks. The middle one is 77.23. Okay, this is only thing that you have to understand and remember. The simplest one, okay. For example, chloroform D, what is this? Methanol D. They have singlet at 4.78. They have 5 peak at 3.31. Okay. Okay, make sure you remember this one. Okay, read, and if you can memorize, memorize the important peak only. For example, if we use commonly the solvent with chloroform D, so proceed with the chloroform D. Okay, this is the NMR level. Okay, so we put the sample and we put the samples. We put the samples like this, and we have to measure this one. Okay, first you have to check the sample and put inside the spinner. This is very important. And you have to adjust the depth of gauge. For our cases, don't do that because we already do it for you, because this is the normal level, gauge level for the 5 mm NMR. If you use non 5 mm NMR tubes, so please let us know, okay, and we will adjust for you. Okay, so make sure the NMR tube is not bent. Okay, normally what students love to do is cleaning and put inside the for example, this one is the beaker, and put like this, and if you realize sometimes they will bend, slightly bend, okay, but if that happens, you have to throw this NMR tube. Okay, it's better to put clean the NMR tube and put in the aluminum foil, make a boat and put like this, and put inside the film, put inside the ovens. It's around 40 degrees, not more than that. Please do it. Please don't put more than 40 degrees, because you know when you increase the temperature, the glass will be expand, something like that. Okay, because our concern is when they goes to the probe, they will spin. Okay, the experiment will spin. If the spin is not correct, this will be like this. Sometimes it will be hit the inner layer of the probe, and it will be broken. It's happened several times. Okay, so make sure you have the correct level for the NMR samples, and after that you put inside the probe, superconducting magnets. Okay, so this is the gauge or the sample adjuster. Okay, so this is the spinner. Okay, for the broker types, we have the plastic spinner, but make sure when you try to put the samples inside, and put the sample inside, the ring, sample inside. Okay, so make sure it's not loose. Okay, if they're loose, when they try to put inside the superconducting, it will break. Okay, there is another job for me, so I have to lean and try to remove the probe from the bottom, uninstall the cable, do it again, cleaning and something like that. I will lose 1 or 2 days to do that. Okay, okay, please be careful with your own samples. Okay, don't say you don't know. Okay, for the jewel, there will not plastic types. There will be another types. For the sample that require the high temperature, we will provide the quartz. We have these types of spinner that make from quartz. Okay, and that one especially for anybody who working on polymers. So something interesting about the spinners, when you try to prepare the samples, you have to wipe. We have to wipe with, usually we use ethanol and in tissues. soft tissues and wipe the surface because we want to remove the grease. Okay, and after that, put carefully inside the spinner and make sure you don't touch this black and white area, because this one, when they try to spin, the NMR, when they try to spin, they will calculate how many RPM, how many circle they have done, because they are using binary code. Okay, one is yellow is 1, black is 0, and they will have these calculations to make sure how many spin, how many fast the sample spin inside the probe. Okay, so this is how we measure. We put the sample on the top, okay, and make sure your solvent levels, that's why I asked you to prepare around 3.8 to 4, because the magnet will bombard from this area and they will measure from here. Okay. Okay, this is kind of sample preparation. Yesterday I prepared with Idris. Okay, it's in a good condition. This 4 centimeter here. Okay, so again, make sure everything don't touch this area. This is very important. Make sure the NMR tube is not loose. Again, we can see here, make sure this part is filled with the solvents. Okay, and again, I will repeat again. First, you have to average appropriate weight for NMR, okay, samples, and you have to select the correct NMR tube. So right now they have no issue for the number 2. We have only 5 mm diameters. So I'm order another I think I'm not sure how much the NMR. I think 50 more NMR tube, and I will keep in my office. Anybody who need the NMR can come to my office. Okay, and also we have a lot of NMR without caps, so we already ordered the caps, so hopefully they will come soon. Okay, and number 3, selection of deuterated solvent, and you have to understand the reference and remember the reference. This is very important. Okay, and again, the solvent level for the deuterated solvent is around 3.8 and 4.0. The first one is because the effective measurements. The second one is for the cost assessment. Okay, because the deuterated solvent is quite expensive. 100 ml for CDCl3, it costs 500 to 400 ringgit Malaysia. I guess around 100 to 120 USD. Okay. So for the NMR experiments, okay, we go to the second one. In general, about the NMR experiments, you will have to understand about the gyromagnetic ratio. Okay, they have 2 different gyromagnetic ratio. The first one is proton, the second one is carbon. That's why if you remember, why carbon 500 megahertz and the carbon, the proton is 500 megahertz, but the carbon is 125. This is because of this. Okay, the gyromagnetic ratio for the proton is higher 4 times compared to carbon. I just give you the answer for these questions. Okay, so if you have a chance to operate the machines, okay, they have one part. They will ask about number of scans. How many scans you want? It will be represent the how long experiment you need to do. Okay, okay. You can use actually there's another formula, but to make it easy for you, you can put any number that can divide by 4. Okay, for the 1H experiments, okay, the pulse program is ZG30. For the 13 carbon, ZGPG. So they will have a, you have to remember this one if you have a chance to run by yourself. Okay, so you have to understand the difference between depth experiments. For example, if you have if you measure depth 135, okay, you can get methyl, methylene, methine. Okay, so for the depth or CH only. Okay, for the depth 45, CH3, CH2, CH. For example, anybody who are working on nature products, okay, I strongly advise for especially for the complicated compounds like Solihin, Amira, for the complicated compounds. Okay, right now I have these two person only. I try to solve the structure. So try to have that 135, okay, a carbon, that 135 and that 90. So after that you can differentiate all the class of carbons. Okay, for example, for carbons, they are measure all the carbons peak from the quaternary until CH. Okay, until CH3. So for the depth, they will measure of CH. You can eliminate which signal it represent as CH. They will help you a lot. All information will help you a lot. Okay, for the COSY, they will measure the neighboring protons, proton-proton interactions, neighboring only. They have exceptional principle when the system is JW coupling. So we will discuss later. So for the HSQC is only for J1 coupling. It means carbons, where is their protons? Okay, for the HMBC, you have to measure the carbon with neighboring protons. There we have J2 and J1 correlations. If your samples a very small quantity, there is new experiments, we call that Q. The principle is similar like carbon and also that 135, but they will measure also the quaternary carbon. So this is the new experiments I learned in 2014. For NOAA, this is last year experiments. If you need the experiment urgently, okay, with two complete set of 2D experiments, you can use NOAA programs. At one time, they will measure all 2D experiments. For example, you send the parameter to measure COSY, HSQC, HMBC, and noisy. They will measure all the time at the same time. Okay, this is very effective and also save time. Okay, I have tried once with the Indonesian samples and it's working. So NMR top spin processing software. So I just want to introduce you. This is I taking from the NMR Broker website. Okay, there's a new latest release of top spin. They already reached to 4.1.3. So I guess with your software, I think is 3.6.2 is the previous one, but I'm using 3.6.2. This is okay for the one because 4.1.3 is still a beta versions. Okay, so what you need to do it, you have to enter this website, okay, and click here to registration. You have to register and declare you are a student or working in academia because this is the non-profit license. Okay, so for example, you have to log in everything. Okay, and again you have to install to this website. Okay, and click here to retrieve this license. Broker.com registration required. So I will open the website. So when we open the website, it's become like this. Okay, and you have to choose TopSpin Windows, Linux, Mac OS. Mac is complicated, to be honest, because I have Macs and already installed. It's really complicated, so I have to buy another laptop with the Windows operating system. So it's better to have Windows because to transfer the data to view the spectra is quite tricky. Okay, and request academia license. For anybody who are not installed, please do it so. You can call the seniors here in the group WhatsApp. I already put everybody there. So you have to install. They have two software that you have to install. The first software is NMR. The second one is ChemDraw. Okay. The rest like Avogadro software to minimize the the energy, something like that, is additional because anybody have their own interest to do the modeling, for example. But this software you should have inside your laptop. Okay, so and wait. So for the NMR result processing, okay, usually we have the provider, so the company will give you the software to process the NMR. For example, in Japan, they are familiar to use Joule. So the Joule is a Delta software, and you can use that one. Okay, I have both experience you working on Broker and also Joule. So I think Broker is quite friendly user compared to Joule. It's complicated because we have to manual shim, something like that. Okay, during my time. Okay, so NMR Notebook is the French company software. They have an academic license. Okay, so I have this. If you see, yeah, I have one software with NMR Notebooks. Yeah, let me open this software I get when I'm in France. The second one is ACD Lab. Previously it's free, but now you have to pay for ACD Lab. Okay, so the next one is MNova, Max3 Nova. So it's a quite tricky software also, but it's an open source software. You can use with ACD Lab, NMR Notebooks, and MNova. You can use with all operator, all brands of NMR software. This is the NMR Notebooks. You, for example, open here, extract the data, so you will call the NMR. Okay, so another one is another one. I'm trying to open the MNova. I have 3 NMR software in my computer now. So anybody who need MNova, yeah, can come and see me. I have the software. I just get last 2 weeks from my colleague from France. So, but you have to explore by yourself. Okay. Okay, this is the MNova interface for NMR processing tools. Okay, so just open everything's. Okay, similar like words, something like that. Okay, so for a few things that you have to know and understand. The first one is integrations. This is very important for the integrations. How to do the integration we will do after this. Peak picking, okay, phase corrections and calibrate axis, and 2D NMR processing spectrum process. So this is what we will cover today. Okay, so step-by-step analysis, we will go for the proton first, carbon, depth, 2D HSQC analysis to determine the proton signals, COSY, determine the neighboring proton, J1, okay, HMBC correlations with proton and carbons, and noisy correlation between space